The last part of this question, part D. It is possible to project the stone in C, and there's a stone in C there, with the same speed but at a different angle to the horizontal, so that it has exactly the same horizontal range as in C part 1. Copy this figure into your exam booklet, and on the same diagram draw a labelled sketch of the trajectory obtained with this alternative angle of projection. No calculation is required. State with a reason whether the time of flight with this second trajectory is less than, the same as, or greater than the time of flight when the stone is projected with a velocity of 25 metres per second at 35 degrees to the horizontal as in C. No calculation is necessary. Now, just to have we think about this, you know that, okay, so we'll just do this bit on the, a piece of file paper again. So we have got an equation for to calculate the range, and the range is equal to v squared, which is your original velocity of your projectile, times the sine of 2 theta divided by g. And we know our range, 60 metres, is equal to 25 squared, the sine of 2 theta, over 9.81. So whenever you rearrange that, 2 theta has got a value of 70 degrees. But you should know from maths that if we think about the angles in which the sine of theta is positive, one of the places that it's positive is in that first quadrant, but it's also positive in the second quadrant. So if we have our 2 theta is equal to 70 degrees there, we could also have a value in this quadrant which will give us a positive value, provided this angle here is also 70 degrees. So that means that 2 theta is 70 degrees, or 180 minus 70, which is 110. And therefore theta could either be 35 degrees or 55 degrees. So that means whenever you draw this out, I'm not going to draw it out, I'm just going to show it to you on here and scan it a wee bit. If you were to draw that out, then if you shot your projectile at an angle of 55 degrees, you would expect to get a trajectory like that. And this is your new angle here, call it theta, and theta equals 55 degrees. Now, we're told that the range is the same horizontal range, and it will therefore have the same vertical velocity, horizontal velocity. And since speed is distance over time, horizontally, if that stays the same and that stays the same, then the time must stay the same as well, because you've got the same range. Sorry, I realise you can't see that. You've got the same range and the same speed, because the sine of 55 will give you the same answer as the sine of 35. Or sorry, the sine, it was really the sine of 110, 2 theta is going to give you the same value. And so the answer there is that you're going to have a trajectory which is higher. There's a trajectory there. You're going to have a second angle of 55 degrees. You're not asked to calculate that, but we've just done it. And the last thing there then is that your time will be the same. I'm not sure if you were able to see that. I think you were actually able to see that there, CAST.